This time around, we are talking loops, and this is a very powerful tool for repeating ourselves without actually repeating ourselves. So, diving in, we're going to talk about what loops are. We're going to look at the three main types of loops that you're going to see as a programmer, that being the for loop, the while loop, and the do while loop, which doesn't necessarily exist in Python, but it is something we're going to take a look at regardless. And then I want to talk a bit about nesting statements, because this is something that is very important. It's something that you're going to see a lot of. Pretty much, you're going to see it in all your code from here on. So, diving straight into it, what exactly is a loop? A loop is another form of control flow, or it's a control flow tool that is used to repeat the same code more than once under a certain set of conditions. And essentially it solves the question of how do we do multiple tasks with one chunk of code. So say you want to enter some data, you have a bulk set of data, and you want to enter it into a database. Well, you can do that with a loop by having the code take each piece and enter it, and then go to the next piece, enter that, go to the next piece, enter that. You're doing the same thing with different pieces of data. So, there are two ways that a loop will stop its execution, and this defines our two main types of loop. The first is that some condition that is established is no longer true. So say you are dividing x by 2 every time you do an iteration being a single pass through a loop. And when it is no longer greater than 10, that's when the loop ends. We break out of it, we move on. Or when an end of the sequence is reached. This is the backbone of the for loop. So, how many times can a loop execute? It depends on the loop. It can execute 0 times, it can execute only a single time, it can execute an indefinite number of times. It all depends on how the loop is set up, what kind of loop you're using, and what kind of data you're feeding it. So, a quick side note is on the subject of recursion. This is a concept that predates loops. It's sort of the predecessor to them. And this is something that you're going to see in your future classes. You're going to learn actually how to do a recursive piece of code. And the idea is very similar, but instead of just repeating the code must call itself if it is not done executing. It is not often used today, but it does have its applications for things like pathing and factorials and similar calculations. So you will see recursion come up, just not terribly often, because it can lead to some major stability issues if it is not done correctly. You'll get what is called a stack overflow if your recursive code does not have a termination point that it can reach. That is named, of course, after the forum where you guys are getting some of your answers, I have no doubt. So, recursion, very important. Not going to use it right now. Be aware of it because it will come in handy in the future. So, let's move on to talking about our specific types of loop. Like I said, we have 3 that we're going over. The 2 main ones are the for and while. So let's look at those. So our for loop is intended for iterating over a sequence, whether that be a set, a tuple, a dictionary, a list, a range of numbers, so on and so forth. A for loop is intended to take each item in a collection and do something with it. How many times it executes depends on the size of the sequence, and of course that can potentially change if the operations inside the loop add to the sequence. So It is generally used when we know exactly how many times we want to iterate over something, or when we know we are iterating over some kind of collection, whether it be a string, a list, a dictionary, or whatever. Now, there are two styles of for loops. The old style is one you're going to see when you get into C++ and other languages, and that is for iterator, in our case I, equals 0, semicolon, I less than 10, semicolon, I plus plus. Remember that plus plus is your iterator. Now what this is saying is exactly the same thing as with the new style, for I in range 0 to 10. It's going to do something at the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember with range that the last number is excluded. Keep that in mind. So when you say range 0 to 10, you're actually using numbers 0 through 9. But these two loops say the same thing. And we're going to see a lot more examples of how these work. So here's our code. In Python, we have for I in range 0 to 10. This creates a sequence, not a list, a sequence of numbers that range, again, from 0 to 9. So we have that, then a colon, and then we have our code inside, print I squared. Remember that I stands for iterator or incrementer, and this is a very common index value for loops. Python has other ways to write for loops that do not involve an iterator. We will get to those when we do some examples, but for now, just understand that this is the most basic form of a for loop. For I in a range of numbers do some kind of task. And you can see the flowchart here on the right visualizing it. For loops are very, very simple. Moving on to our while loop. While loops execute until their condition is false. It is possible for them to execute none at all, as the condition is checked before the iteration can begin. So if you reach a while loop and the condition is false on the first iteration, it's not going to do anything. It'll just skip the loop and move on. In essence, you could think of a while loop as a repeating if statement. We check the condition. If it's true, we do the code inside it. Then we come back and we check the condition again. And we keep doing that until the condition is false, at which point, like an if statement, returning false with its condition, we exit and move on. So again, on the right, you can see a flow chart describing how it works. On the left, you can see the code. So we have x equals 5 and factorial equals 1. We're going to perform a factorial operation. So we're going to say while x is greater than 1, factorial equals factorial times x. You could say also factorial times equals x. That is also valid. And so what's going to happen here is after that we subtract 1 from x. And what will happen here is we are saying factorial, which is currently 1, is going to be equal to itself times 5, so then it's 5, decrease x to 1. It's still greater than 1, so factorial, which is 5, is multiplied by 4, which is 20. And it'll repeat. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is skipped. Well, no, it is skipped because 120 times 1 is not going to do anything. So, once we reach 120, we're done, and we have a completed loop, and we've solved our factorial. So this is how a while loop works. Remember, condition is checked before iteration. So it is possible for this to execute 0 times. It is also possible for it to execute an indefinite, potentially infinite number of times. Next we have the do-while loop. The do-while loop is the same, in essence, as the while loop, but with one difference. The condition is checked after iteration, guaranteeing that the code inside the loop will be executed at least once. Is guaranteed to execute once, not guaranteed to execute more than that. It all depends on the condition. Now, something important to note is that Python does not have a do-while loop. C++ and Java most certainly do have do-while loops, but Python does not. Does that mean we can't take advantage of it? No, we just have to emulate it using a regular while loop. So you can see how that works here. And we're doing this with a new command that we have yet to see called break. What break does is it forcibly terminates the structure that it's contained in. So here we have x equals 25. We're saying while true, we're going to print x squared. Because we are giving our while loop just a true, it's guaranteed. It's always going to execute. This is a potential infinite loop, so you need to have some way to break out of it. So while true, print x squared and subtract 1 from x. And at this point, if x falls below 10, then we exit our while true loop. We're going to do tons of examples, make sure we understand all the different ways we do these, and you will benefit from knowing how to write a do-while loop in Python, but just know that you have to emulate it using a regular while loop. But whereas in C++ and Java, there is an actual do command that starts a while loop. Now, a side note about nesting statements. You're going to be doing this from now on. You're going to have something inside something. And what can you put inside of each structure? What can we put inside an if? What can we put inside of a loop? What can we put inside of a function, a match case statement, which we're going to talk about in the next set of lectures? The answer to that question is anything. Anything can be nested inside anything. It's just a matter of when and where it's appropriate. So, is it appropriate to nest a function inside of a loop? Like a function definition? Probably not. A function call, obviously, that's going to be acceptable. But if you have an else that needs an if inside of it, you can do that. You can say else colon, and then on the next line, indented, you have another if statement. Nesting is completely flexible. You just need to use your best judgment to know when and where you need to use it. And a good rule of thumb is if you need to nest more than 3 or 4 layers inside your code, you might need to flatten it out by creating some other constructs, which we'll get into as we go along through the course. But I just want you to understand the importance of nesting, why it's important to know that you can nest anything in anything. And I want you to be sure you're taking plenty of time to practice. So, next lectures, we're going to do a few examples of while loops, do while loops, and for loops. So, stick around for that.